Okay, this is your last FRQ. It's the 2002 free response. It is about operating cost and the number of passenger seats in an airline company. So make sure that you try to answer these questions and then come back to this video. So I'm not going to read the whole thing, but this is talking about commercial airlines and the operating cost per hour with the number of passenger seats on the plane. And this sample included planes with as few as 216 passenger seats and as many as 410 passenger seats. And notice that I circled these because when I was reading, then I noticed that this is your response and then this is your explanatory. Of course, you could pick that out anyways because you see the scatter plot. So, all right, then we're going to look at the computer output and see if we can pick out everything that we need. So you'll notice this is always going to be your x context, which it is, and this is your slope beside it. So slope is here. So this is slope. Constant is always your y-intercept. Okay, we don't need this. This is r squared. So r squared is 57%. And this is the standard deviation of our residuals. So in case we need any of that, we don't need this. Okay, so number one said, what's the equation of the least square regression line that describes the relationship between operating cost per hour and number of passenger seats in the plane? Define any variables used. So you want to always make sure that you write this, no matter what, write it in words the way I told you to in class. So if you'll notice in stats, we put the y-intercept first, where it's usually mx plus b, but it's kind of doing that backwards, okay? So the first number is always your y-intercept, then the second one's your slope times your x context. Okay, so predicted operating cost equals 1136, which is your y-intercept, plus 14.673, which is your slope, times your x, which is number of passenger seats. So notice I just wrote that out. Okay, if you do that, you're going to get it every time. So that's what I would do. All right, so B part is if you just had just y and x, you would have to write out y equals operating cost per hour and x equals number of passenger seats. So it's easier just to do this. All right, so B part says what is the value of the correlation coefficient. So make sure that you know what that means. What does correlation coefficient mean? That means your R, okay, for operating cost per hour and number of passenger seats in the plane. So interpret the correlation. So first let's talk about how we're going to get the correlation. For correlation, it doesn't tell you it's R. You have to know that it's R. So I know that R squared is 57%. Well, I can't take the square root of both sides if it's in a percentage. I have to write that as a decimal. So 57% is the same thing as 0.57. Okay, so then to get R, I'm going to take the square root of both sides. So R is equal to, now do notice that you have to pay attention. For instance, if this was a negative correlation, your R would be negative, because y'all remember plus or minus in algebra. So you're not going to, this is not going to be a negative number. So you've got to know, obviously this is a positive correlation, but just so you know, if it was negative, you would need to make sure you put your R as negative, and a lot of times you'd forget to do that. But the square root of 0.57 is 0.755. So that is your R. But just know, if it was a negative correlation, you would need to put like negative 0.755. Okay, so that's R, but we have to interpret it. And so how do we interpret that? Basically, we're just going to do DUFs with no U. All right, direction is what? Positive. What is the form? It's linear. And then it has to be linear with correlation. And then your strength is 0.755 is fairly strong. Okay, so we're going to write that out in words. Okay, I didn't realize I was recording. I should have paused that. But so there is a positive, fairly strong linear relationship between number of passenger seats and operating cost per hour. So that's all we've got to do. Like I said, I should have paused the video. I didn't realize I was still playing it, but that's okay. So that's the interpretation. You have to have positive. You have to have fairly strong, or you can just say strong. You could even probably get away with moderate, but I think 0.755 is a little bit closer to strong. Linear relationship. So remember, if you're interpreting the correlation, it has to be linear. So let's go to C part. Okay, C part says, suppose you want to describe the relationship between operating cost per hour and number of passenger seats in the plane for planes only in the range of 250 to 350 seats. Okay, so we're going to go, this is 200, this is 300, so we're talking about, this is 250. So we're talking about from here to 350, well, that's here. Okay, so we're just going to look at just that. All right, so then I want you to think about that and think, okay, we're only looking here to here. Okay, now it says, does the line show in the scatter plot still provide the best description of the relationship for the data in this range? Why or why not? So if you'll look here, is the relationship still positive? You see that there's actually a negative correlation from 250 to 350, even though the entire thing as a whole is a positive trend. So the whole thing is positive, but if you look at just a little part of it, then it's actually negative. Okay? So what we want to say is, we want to say, no, it's not the same as this, right? Because this has a positive correlation, because it's got a positive relationship. We would need to say it's actually going to have a negative correlation. So we want to say that in words. Okay, so I said no between 250 and 350 seats. Also, make sure you use context with anything, okay? There is a negative relationship between the number of passengers and operating costs. I used my context. I also added that this would result in a negative slope. You could say it also results in a negative correlation, but somewhere in here you got to say something about a negative relationship. I put that in there twice. But if you don't have something about it having a negative relationship, you would not get credit. If you do not have context, you would not get credit.